So here we're going to start looking at partial fractions. In particular, the kind we're going to look at are the distinct linear factor kinds, but we'll worry about that more in a little bit. So hopefully by now we should be able to add together two algebraic, but we'll spell algebraic right. Algebraic fractions. So for example, 3 over x plus 2 plus 2 over x plus 4. Right, that's the thing that we should be able to do by now. So all we're going to do, multiply each side. So we've got a common denominator. We've got 3 lots of x plus 4 over x plus 2, x plus 4 plus 2 lots of x plus 2, again over x plus 2, x plus 4. Bring it together, start multiplying it out, so we get 3x plus 12 plus 2x plus 4 all over x plus 2, x plus 4, and then we'll tidy it up and we'll see what we've got. So we end up getting 5x plus 16 over x plus 2, x plus 4. Right, so that should be a thing that we're comfortable with by now. But what we're going to look at in our partial fractions is we're going to go the other way. And what we want to be able to do is we want to split these back up. Okay, so our partial fractions just involve the reverse of this process. Okay, so for example, looking at our distinct type, so sometimes see them referred to as type 1 as well, but now we're going to take a fraction and let's go for, let's stick with 5x plus 16 over x plus 2, x plus 4, and then we can see whether or not it works out. So what we're going to do is we're going to say, right, well, we must have started with two fractions here. It must be something over x plus 2 plus something else over x plus 4. And it's important that when we're dealing with this, we've got this bit here on the bottom of the fraction factorised as fully as possible. Okay, and we'll look at instances later where it's not possible, but just now it is. We've got it factorised, so we can run with that. So one fraction for that one fraction for that one. Next thing I'm going to do is I'm going to multiply throughout by x plus 2, x plus 4. And what that is going to do is that's going to get rid of the denominators in every one of my fractions. And so I'm going to have 5x plus 16 on the left is equal to x plus 4 lots of a plus x plus 2 lots of b. Okay, so what we're going to do now is to find a and b, we are just going to substitute in different values for x to solve the resultant equations. So how does that help? What does he mean by that? Well, we're not just going to pick any numbers for x. For example, let x equal minus 4. And so into every part of this new equation we've got here, we're going to sub x equals minus 4 in. And so I've got 5 lots of minus 4 plus 16 is equal to minus 4 plus 4 lots of a plus minus 4 plus 2 lots of b. And when we're doing this, the benefit of this should be that one of these things is then going to turn to 0. And so what I've got there is minus 20 plus 16. So I've got minus 4 equals 0 lots of A plus minus 2 lots of B. And so I've got no A's there. And I've got minus 2B. And so minus 4 over minus 2 is equal to B, which is equal just then to 2. What I'm going to do is I'm going to do the same thing, but I'm going to pick minus 2 this time. Again, looking at this equation up here, I want the other one to go away, and so I've got 5 lots of minus 2 plus 16 is equal to minus 2 plus 4 lots of A plus minus 2 plus 2 lots of B. 5 times minus 2 is minus 10. So we go minus 10 plus 16 is 6 equals minus 2 plus 4 is 2 lots of A plus minus 2 plus 2, 0 lots of B. So I've got 6 is equal to 2 lots of A, so 6 over 2 is A, which is 3. And so what we have said then is therefore, okay, let's try and go think about what we had. We've got 5x plus 16 over x plus 2x plus 4 is equal to, well, what did we have here? We found A to be 3, so we get 3 over x plus 2 plus 2 over x plus 4. And if we go back up to the top, 3 over x plus 2 plus 2 over x plus 4 is exactly what we started with. So here we're in this kind of unique position that we can actually check our answer and verify that the process that we've just done here is correct. Okay, that is what I'm looking to do. So let's try another example. Let's do another one. Why not? So we want to express 23x plus 8 all over x plus 7, 2x minus 3, and partial fractions. So first thing we're going to do is we're going to take our 23x plus 8 over x plus 7, 2x minus 3, and we're going to check and see. Now it's already factorised, okay, and I can't factorise that any further, so I can already split it up to be something over my first bracket, something over x plus 7, plus something else over 2x minus 3. Then I'm going to multiply through by my denominator, so I get 2x minus 3. That is going to then leave me with 23x plus 8 equals 2x minus 3 lots of A plus x plus 7 lots of B. Okay, so first thing I'm going to do is we are going to start trying to solve these. I'm going to pick some values. Nicest one is going to be to let x equal minus 7. Okay, so I'm going to have 23 lots of minus 7, which is minus 161 plus 8. We'll find out in a minute if that's wrong. A little bit of faith. 2 lots of minus 7 is going to be minus 14, minus another 3 is minus 17a, and then if I put minus 7 into this bit, it gives me 0, and so that's where we end up with. And so minus 161 plus 8 is minus 153, which is equal to minus 17 lots of A. Minus 153 over minus 17 is equal to A, which is equal to 9. So it does work. There we go. And so we've got our first value. What we can do is, if we want to try and avoid putting in fractional things, now that I know one of the values, I can use that to help me. So instead this time, I'm just going to say let x equal 0. Okay, and so we'll see how much that helps. If it's 23 lots of 0, is 0 plus 8, so I get 8 on the left hand side is equal to, sticking my 0 into the next bit then, I've got 2 lots of 0, 0 minus 3, so I've got minus 3 lots of A plus 7 lots of B. So following this through, I've got 8 is equal to minus 3 lots of, well, I know the value for A now, because I've just worked that one out, so I can substitute that in as well. So I've got minus 3 lots of 9 plus 7 lots of B. Minus 3 nines is minus 27. So A is equal to minus 27 plus 7B. Take that over to the other side, and so I end up getting 35 is equal to 7B. 35 over 7 is equal to B, which is equal to 5. And so what we can say then is that 23x plus 8 all over x plus 7, 2x minus 3 is equal to 9 over x plus 7 plus 5 over 2x minus 3. And this is a skill that we're going to use a lot more further down the line, and it's going to come in handy, especially when we start to look at integration. Okay, so just now it feels like we're just doing stuff for the sake of doing stuff, but actually, as you can progress further down the course, this is a really handy thing to help, especially when you've got integration things to do. We'll cover that in due course.